Welcome. In today's session, we'll be looking at the histological organization of the spleen. So the spleen is the largest lymphoid organ. I should show you those notes. Spleen is the largest lymphoid organs. So it is encapsulated. It usually filters blood and immunologically monitors blood. So that is one function. Another function is that it is the site of red blood cell production in fetus, but in postnatal life, it is the graveyard of the red blood cell. So essentially, they usually produce red blood cells in the fetus, and later, postnatally, it destroys the old ones. So it has the stroma and the parenchyma. So the stroma consists of the capsule and the trabeculae of the septa. The capsule is dense connective tissue enclosing the organ. So this is the capsule. Here maybe they should do that. So this is the capsule from here up to there. You can see it is dense, like dense connective tissue. It has a myofibroblast. You can see these nuclei. I don't know if I can magnify more for you to see those nuclei well. Yes. So you can see these nuclei. These flattened nuclei are for the myofibroblast. The myofibroblast usually contract and aid in the discharge of the red blood cells in mammals. So another function of the spleen is storage of blood, but that function is not prominent in man, but in animals such as dogs or horses, they store a lot of blood. So the capsule, and it receives no afferent. There are no afferent lymphatics. So no lymphatics usually come into the spleen. So the capsule usually send in trabeculae. I said, remember the trabeculae usually contain the blood vessels. In this case, they contain only blood vessels, no lymphatics, only the arteries and the veins. So you can see a blood vessel. This is a very good section of a blood vessel. This is a very good blood vessel on the trabeculae. So this is another blood vessel. Maybe I should for you to see clearly. Remember the blood vessel, the histological organization of blood vessels, biliaris, tunica intima, tunica media, tunica externa. So you can see here, this is the endothelial lining, the tunica intima, and another day of the histological organization of the blood vessels. Then that was the parenchyma. No, sorry. That was the stroma. Am I sleeping? Then we have the parenchyma. The parenchyma is divided into two. We have what is known as the white pulp and the red pulp. White pulp is an immunological barrier, where the red pulp is involved in blood filtration. So let's look at this. So the white pulp is composed of lymphatic tissue. It appears basophilic due to the large number of nuclei. So we will have what is known as splenic nodules. So splenic nodules are like these ones. This is a splenic nodule. This is a splenic nodule. You can see we have a germinal center and a mantle zone. Germinal center, remember germinal center is where we have actively dividing B lymphocytes. Why B? Because that B stands for the basa of Fabricus. It's a cloacal diverticulum in the members of class Aves. It's responsible for, in birds, it usually produces B lymphocytes. But remember, in humans, B lymphocytes come directly from the bone marrow and into the lymphoid tissue, where they will undergo activation. So this is the germinal center. Then the mantle zone is composed mainly of just the B lymphocytes, aggregation of B lymphocytes. This is where they are actively dividing the germinal center and the mantle zone. That is where they are like chilling there. They are waiting at activation there. So, what else about the white part? So we also have, remember the arteries, the trabecular arteries. They are usually coated by mainly the central the splenic artery usually divide into trabecular arteries. Trabecular arteries, they usually give off central arterios and the peninsular arterios into the white part. These arterios are usually coated by lymphatic tissue, what is known as the periarterial lymphatic shield. So maybe if you look at the periarterial lymphatic shield, some people might confuse it with the nodule, but this is what I want you to see. Maybe I should. So you can see this is the arterial here, but you can see it is surrounded by lymphatic tissue. This is known as what is known as the periarterial lymphatic shield. So what is the difference between a nodule and a periarterial lymphatic shield? A periarterial lymphatic shield has an arteriole. So you can see where the arteriole is here. I should magnify more for you to see it clearly. This is the arteriole here. So also remember, nodules are mainly composed of B cells, B lymphocytes, sorry, but the periarterial lymphatic shield is mainly composed of T lymphocytes, which originate from the thymus. Also see this is another one, another arteriole here in association with this lymphatic tissue. This lymphatic tissue here, the periarterial lymphatic shield. Then we have some areas between the white and the red part known as the marginal zones. The marginal zones, like this is a marginal zone here. So you can see this is maybe I should. You can see this is one. Sorry for that. This is one. This is a white part here, another white part here. Then you can see this region in between the marginal zone, that is what is known as the marginal zone. So the marginal zone, it has some cell types. The main cell types here are the macrophages, the dendritic cells. You can also find there the lymphocytes. So in the marginal zone, we have those ones. Maybe that is what we can say about the white part. Remember, we have the periarterial lymphatic shield. It is the one which surrounds the central arterioles and mainly composed of T lymphocytes. Yeah, let's look at the red part. So that was the white part of the parenchyma. So the red part, I said, is for mainly involved in the filtration of blood, and it filters and degrades red blood cell. It appears eosinophilic due to the large number of red blood cells. Remember, the white part was basophilic. So the red part, this is the red part. Even you can see for yourself, it is somewhat red. So it has, within the red part, we have vascular channels known as the splenic sinusoids. And in between those splenic sinusoids, we have cords, the splenic cords of B-rod. So maybe I should show you a splenic sinusoids. So the splenic sinusoids, this is a splenic sinusoid here. These are the splenic sinusoids. They are vascular channels. They are endothelial cells. They are somewhat, they are composed. They are endothelial cells. The endothelium is composed of stave cells. It has stave cells. You know, like those wooden posts, how they look. Those cells usually look like that, and they usually have they are like perforated to allow entry and exit of the red blood cells. Also, we have macrophages, which usually extend their pseudopods into the splenic sinusoids for screening of antigens, screening of blood. So the splenic, I said the splenic sinusoids are separated by the splenic cords of Birod. So the splenic cords of Birod is simply a meshwork. It's a meshwork. Like this is a one sinusoid here, and this is another one. You can see in between you have cord-like some cords, the splenic cords of Birod. So they are mainly composed of, we have reticular cells and fibers, macrophages, we have antigen presenting cells and red blood cells there. So the splenic, as I said, the splenic sinuses here, you can see these splenic sinuses. You can see here we have like a group of cells, and here between we have a gap. So through this gap, you can have entry and exit of red blood cells. Also, the macrophages usually extend their pseudopods into the splenic sinusoids to screen the blood for antigens. So the sinuses do not have a continuous basal lamina, as I've said, to allow entry and exit of red blood cells. Macrophages usually send their pseudopods through the spaces to screen blood for antigens. Then in a separate section, I will do the circulation within the red part. Today we are looking just at the histological organization. But we have remember the central arterios were surrounded by the periarterial lymphatic sheath, but these pulp arterios, they are not. Like this is a pulp arterial here. I showed you a pulp arterial. This is a pulp arterial. You can see it is not surrounded by the T lymphocytes. Then we have others known as the sheathed arterios. They are surrounded by macrophages. So, yeah, this is a sheathed. These are macrophages surrounding it. So remember, macrophages are phagocytic. They usually phagocytose let's say a pathogen, they phagocytose it. Yeah, that is the histological organization. Maybe I show you. Yes, maybe I show you just there. And see the reticular fibers. This we have used some. This is the silver stain. You can see this is the splenic sinusoid. Then in between, this is another one. You can see here we have this is the splenic cords of Birod. You can see these are reticular fibers. These are reticular fibers. So, yes, maybe just that I had today. So you can see this is the splenic sinusoids. You can see a very meshwork of the reticular fibers. Reticular fibers is like very collagen. So thank you guys, and that was the histological organization of the spleen. Thank you. Subscribe for more.